Hello all, I'm here to talk about PREPchain, a proposed tweak to blockchain consensus that reverses the large-scale climate impacts of blockchain technology while making blockchain more secure and decentralized. In this network, block ceiling capacity is proportional not to energy burned or money posted, but electricity produced from renewable sources which can then be used for any purpose. As a brief introduction to your speaker today, I have degrees in electrical and computer engineering and community development, during which time I focused on solar power, cellular automata models that let us study emergent properties of simple interacting units, and how technology is changing society. During this work, the U.S. federal government selected me as a Udall Scholar for a career commitment related to the environment, and it was a question from that alumni network that really led me down the rabbit hole into blockchain tech. These bachelor's fields merged in grad school with a master's in computation, organizations, and society, and a PhD in societal computing, where my research focused on technologies that help very large groups of people work together to solve very complex problems like climate change and internet governance. I then spent a bit over a half decade working especially on blockchain topics with a nonprofit that forms consortia to solve industry-wide problems such as securing the aerospace supply chain. This was through a minority woman-owned tech consulting company, which also supported PREPchain in its very early days. So thanks much to Sigma Resources LLC. We're going to talk about incentivizing objectives. So let's open today with a quote often attributed to Antoine de Saint-Exupéry. If you want to build a ship, don't drum up the men to gather wood, divide the work, and give orders. Instead, teach them to yearn for the vast and endless sea. The longer version of this concept from his 1948 Citadel describes how setting motivations can not only accomplish the goal, but do so in a way that best leverages the unique skills of each individual. First, I'd like to thank Satoshi Nakamoto for coming up with a clever way of structuring incentives that leads to many people working together to produce and maintain a highly secure network that everybody can benefit from without all the drawbacks that come with centralized control. Nakamoto's first application of this technology was a relatively simple payments network, secured through cryptography, and because attacking its security and immutability guarantees would be very costly and noticeable. In Bitcoin's case, that's because it would require burning more energy than the rest of the network combined. Today, the Bitcoin network uses more electricity than some mid-sized developed countries, and even when that comes from a renewable source, it's generally taking away from renewable energy that could be used for homes and industries. This huge amount of electricity consumption has led some regulators to call for banning blockchain technology in their jurisdictions over broadly. As a long-term steady state, we should expect the network's energy use per block to be just under the amount of electricity the total amount of block rewards can buy. For as bad of a reputation as Bitcoin gets, sustainability has been important from the early days in that community. But with so many new concepts being introduced in the first major blockchain, energy consumption that serves only to secure the network by finding a hash below a threshold was the fastest way to make attacking the security guarantees both costly and noticeable. PrimeCoin sought to make the work more useful, finding chains of relatively small probably prime numbers, and it's still going today, but it's hard to get a lot of people excited about the utility of that. Around the same time that he was drafting the Ethereum white paper, Vitalik Buterin cited PrimeCoin in an article about using the minting of currencies as a new way to incentivize production of something that a society values. However, with how hard it is to get that right, and with so many new concepts already being introduced in Ethereum already, there wasn't time to also solve the planetary costs of proof of work. Though the plan was baked in from close to the start of the network, it wasn't until about a year ago that Ethereum radically reduced its energy use, with a shift from Bitcoin-style proof of work to proof of stake, another way of making attacking the security guarantees on-chain costly and noticeable. In a society where wealth is both concentrated and easier to move around than physical facilities that make or use large amounts of electricity, proof of stake is a little more vulnerable to attacks from very well-resourced government and private actors. Although such an attack is unlikely, we shouldn't pretend like very well-resourced actors never take over widely used networks and drastically change their character. If this vulnerability becomes widely salient to a lot of people in a short time, planetary sustainability demands having a better option than proof of work already well tested and ready to go. Proof of renewable electricity production could be such an alternative. It harnesses the billions of dollars going into blockchain technology, even just for gas fees, and uses that economic power to incentivize production of electricity from renewable sources, redirecting a lot of capital without strictly requiring any government action. It's like proof of stake and integrates some concept from that, but biases participation in securing the network and reaping the associated rewards according to the amount of electricity produced from renewable sources instead of the amount of money posted. Many other existing incentives that this would add to are already based on getting reliable production figures, so there are already fraud prevention mechanisms controlling large flows of capital based on production reports. There is room for improvement that could be backported to those other settings. For a proof of concept demonstration, existing production APIs should suffice, and you can already sign up to contribute data from Enphase microinverters. Proof of work and proof of stake present non-trivial entry barriers for new parties who want to meaningfully participate in securing the network. Proof of renewable electricity production can be similar, requiring some existing participants to visit a production site and vouch for certain characteristics of the renewable generation equipment found there, including maximum generation capacity, which can be used as a cap on reports from that site. A fraud challenge mechanism can incentivize development of other checks. For example, if a mid-latitude solar installation is claiming high generation at 2 a.m. local time. PREPchain will be a natural home for other projects that use blockchain technology to enhance sustainability, such as carbon credit trading or sustainable supply chain track and trace, and other projects that are only secondarily valuing sustainability. Even before the merge, there were other mostly proof-of-stake blockchains competing for deployments based on sustainability. PREPchain takes another huge step in the same direction, past the one from proof of work to proof of stake. There's still plenty of work to be done before PREPchain is fully ready for prime time. The first task is to complete a paper that goes into greater depth on points from this summary talk and a few more we didn't have time for. Next is modifying open source proof of stake software to use production data from APIs for a proof of concept demonstration. There's also some cryptonomics and programming work for onboarding and fraud challenge mechanisms, and a moderate technical challenge around memory-efficient strategies for expiration of production credits. This could be done in parallel with building partnerships and assembling stakeholders into an Impact DAO consortium for initial governance of key parameters, guiding some additional technical work, such as improving production reporting reliability. Once the main pieces are in place, we'd be able to build and run a more rigorous test network and identify a production strategy likely to maximize impact, which can involve a new or existing EVM chain. Even after launch, ecosystem development efforts will be important, but working within the larger EVM ecosystem can help a lot with that. There are not that many truly global issues where a very large number of people currently recognize an urgent need to come together as humanity and make some drastic changes quickly, where we also already have solutions that a lot of people can individually roll out, with just a need for better aligned incentives. Climate change is such an issue. Because of the strong need for credible neutrality, there will necessarily be some overly simplistic network rules about the extent to which some renewable energy sources are included. However, it seems possible to come up with a reasonably neutral set of rules that still significantly enhances our shared sustainability goals. There's lots of talk about funding for technology demonstrations that could help accelerate our clean energy transition, but the detailed programs underneath these headlines tend to focus, for example, on ways of making solar panels marginally more efficient, advancing fusion where we have had some recent breakthroughs, improving long-duration storage, or building facilities to make hydrogen. Changing the incentives could have an even bigger impact. If you, your organization, or someone you know would like to learn more or support the effort, please reach out to info@prepchain.net, which you can find a link to from prepchain.net. Proof of renewable electricity production can give us a better planet and better blockchain technology. This project helps address the climate crisis on a national equivalent scale, while also making a blockchain that can be more decentralized and resistant to takeover than the most widely used status quo chains. Let's make it happen.